Hi, in this video, we want to take a look at filtering data in R. All right, so there's going to be two major ways to go about this. There's going to be the base R method, and then with the dplyr package. There are other packages that will also accomplish this for us, but base R, if you're using R, you have base R going. So that, we need to go over that. And then the dplyr package is very popular. It's part of the tidyverse, and it's very common to come across it when you look at help documentation online. All right, so the base R method, what that's going to do, that is going to use logical vectors, so true and false, to determine which rows, which observations to keep. dplyr will also use logical statements, but the notation is very different. And so let's go ahead and dig into it. All right, so this first chunk of code is just to load the data that we're going to use and load the dplyr package. All right, so we're going to load dplyr. And so something that we need to notice, like right off the bat, you'll notice that filter and lag are names of functions in multiple packages. So we know that filter and lag are functions in stats and functions in dplyr. Okay, so if I want to use a function named filter, what R is going to do, it's going to take the most recently loaded package for determining which function to use. So as I have it, my most recently loaded package is dplyr. So it'll use the dplyr version of filter and lag. Now, something that can come up is that a package might load like under the hood because of another package, and I don't know about it. And so it could be unclear about which version of a function is going to be used in my code. I call this package confusion. So what we always want to do whenever possible, we want to use the double colon notation. So we do package name, double colon, function name, and then we write the function as normal. We should do that as often as possible to make sure we don't have package confusion. In this example, I'm actually not going to do it because I'm always doing everything in dplyr. But in other videos, you'll see that I'm very consistent about it. At work, I do it all the time. All right, now here we see that the base package has intersect, set difference, set equal, and union, which are all functions in base R and in dplyr. So we need to be mindful of that. Now, let's get to our data. So the data that we're going to use for much of this is the Star Wars data set from the dplyr package. And what I'm going to do, since I'm putting, I'm putting a document together for people to look at, the original data set is too wide, really, to be manageable for this presentation. So what I'm going to do, I'm going to remove columns so that it just fits on the screen better, that when I print up a row, it doesn't bleed over to another side. And so I'm going to limit it down to name, species, gender, hair color, eye color, height, and mass. Okay. Now this is filtering down to the fields I want, the columns I want. And if I look at the actual format of the Star Wars data set, it's a Tibble. So a Tibble is basically the latest, greatest version of data frames in the tidyverse. Tibbles are great. They have a lot of nice features, but they're not always compatible with non-tidyverse functions. And because of this, I prefer to work with data frames. Data frames are compatible with everything in R. So I prefer to have everything as a data frame. Now, there's plenty of documentation that will say that Tibbles are a special type of data frame, so everything should always work. In the data frame world, that's not true. I know from personal experience. So I like to just drop the Tibble aspect and proceed with it just being a straight data frame. Now, next thing I'm going to do on my categorical fields, I'm going to fill in missing values with a missing level. Okay, so for name, species, gender, hair color, and eye color, so columns 1 through 5, whenever we have a missing value, so this is going to create a true false vector. Whenever the value is missing, I'm going to replace the missing value with the word missing. And I'm going to make it actually the term missing. And that what that will do, that will fill in things so that now I have a new level. I find that this is a lot of times the best way to perform imputation on non-ordinal data when I'm doing machine learning. And now let's do the head function to take a look at what my data set looks like at this point. And we can see that we have name, species, gender, hair color, eye color, height, and mass. And we've got Luke Skywalker, C3PO, R2D2, Darth Vader, Princess Leia, and Owen Lars. All right, now you'll notice that here, hair color is missing on C3PO, and hair color is missing on R2D2. This makes sense, right? They're droids, robots. What are the differences? Now let's go ahead and do filtering. Now, so this was just, all of this was just setting up the data to be used. Now let's actually do some filtering. Let's say that I'm interested in all the characters whose height is between 100 and 150, and that includes 100 and 150. So what's going to happen? This part here is going to create a logical vector that is going to be true whenever the height is greater than or equal to 100. And here, this is going to create a logical vector for when the height is less than or equal to 150. Okay, so these are logical vectors. Now, you'll notice in the middle, I have the and statement. The and, what this does, it says that if I have true, true, the whole thing is true. So if both of these are true, then the whole thing is true. If one of them is false, or both of them is false, the whole thing is false with the and statement. And so this will, what this is going to do is that this is going to keep only the rows that have a height between 100 and 150. Okay, so now let's take a look. What do we get for our output? All right, Princess Leia, Mon Mothma. All right, whoa, what do we have here? That's all missing values. And then, hey, we have a bunch of missing values here. What happens is whenever R sees missing values in a logical statement, it fills the entire row of missing values for this purpose. All right, so this is not good. So what I have to do, I have to make sure I have no missing values in my logical vector. And so when we're filtering, it's easy. I think it's a fair statement to say that R does not handle missing values well when filtering. All right, so here's what we can do. Let's do and or statements. Missing or true is always true, because remember, if I'm doing an or statement, if one of the two are true, then it's automatically true. So missing, I don't need to know. Missing or false is missing, and missing or missing is missing. Okay. And missing and true is missing. Missing and false is equal to false. And missing equals missing. Okay, so let's focus in on two of these. All right, so if I have logical vectors going on, if I have two of them, missing values paired up with true in or statement will be true, and missing and false will be equal to false. Okay, so let's take a look at how this works out. So let's say that I have true, false in A, and we expand out the pattern. So here's all the possible combinations. And then we do and ors. Okay, so if I go through true, true, I'll get true both ways and or. False, okay, that's not too shabby. True, false, false, false. Okay, those are the standard combinations. Now, when I have missing, you'll notice that if I have a missing and true, then I'll get a true with an or statement. If I have missing and false, I'll get false with an and statement. And the same things in this order. And then if I have both missing, then it's just missing. Okay, so what I'm going to do, if I make this here's my V. Now what I'm going to do, I'm going to do an OR statement. So here I want so that the height is between 100 and 150, or it's a missing value. Okay, so if I do or a missing value, you'll notice that all the times that we have missing are included. Every time that the height is missing in the data set, those characters from the movie are included. Now, if I change it up and I go to not missing, then what's going to happen is that it's going to take it's going to take all of the characters that have a height between 100 and 150, and it's going to kick out anyone who has missing height from the data set. This is probably what you want more than likely, but you can see that this filters out more observations. So this code gives me all the characters with the height range I want, and it gives me all the ones that have missing values for the height. This one gives me all the ones that are not missing and have the height that is in the range I want. Now, something I want to go back up to, notice how I have my logical vectors written out. You notice that my inequalities are opening on the right. Okay, this is a convention that I do. I always have my the smaller item on the left, the bigger one on the right. I do this every single time I write an inequality, because what this does, this helps me read my code faster. This way I'm very consistent in what I'm doing. I know which direction it's always going in. It's going in the direction of the x-axis number line, which I find is a better way to write this out. A lot of people don't follow this convention. I think you should. All right, so now let's look at filtering rows with dplyr. Okay, so here's a full execution with all of with dplyr. So here is the data set, and here I'm coming up with a logical vector that I pass into here. So here I have data is a named parameter, and then all of if I start passing in unnamed parameters of logical vectors, then the filter function will apply an AND statement to all of them. All right, so you'll notice that this is an unnamed parameter for this logical vector that's generated, and dplyr has a special function for evaluating between. Now so this is going to give me the same logical vector as I had in the previous example, where it's going to be greater than or equal to 100, less than or equal to 150. So this is a closed interval, just like how I had it previously. And here we can get the result, and we see that's exactly what I had before when I kick out the missing values. All right, so now let's do another one. Let's say that I want to filter Star Wars, and I'm going to set species equals human. Okay. And it just goes through. So the first parameter is the data set, and here is an unnamed parameter of a logical vector. So if I just keep on putting logical vectors in, it'll do an AND statement on it. And here we go. All right, so now let's look at Star Wars data set. Now here I'm going to put the mass over 1,000, and that is Jabba the Hutt. Okay. Now let's do filtering with multiple criteria. So here, actually, let me back up. Here I'm doing equality equal to a character string for my filtering. Here I'm using an inequality for my character string. And I got this from the example in dplyr. Normally I would have 1,000 on the left for this inequality. Now for multiple criteria, I've got, like, one way I can do it is I can put an AND statement between them, or I could just put commas on my own. If I want an OR statement, then I need to actually write it out in this manner of an OR statement like that. And remember, OR statements will return more observations. And so we can see the difference here. Now here, I've got two logical vectors and I'm not applying a logical operation between them. You notice I have a comma. All right, the R interprets this as an AND statement. Notice that I've got 9 rows of data here. If I go back up to the AND statement I had previously, it's got 9 rows of data, and it'll be exactly the same data set. All right, so if you're familiar with the tidyverse, you know about piping. Piping is a very code-wise, efficient way to do things. I personally don't use it very much. I usually use it if I'm doing a group by operation, which is where I usually use it in work. But in general, it's very fast. It's very efficient. It's not as fast as other options, but a lot of people find it easy to read. And so I find it to be a good choice for a lot of things. And so I don't usually use it, but that's just because I'm old and don't want to change my ways. So here, Star Wars, the piping operator, what it does, it takes the output at this point in the code and it passes that into the next function, and it passes it at the first unnamed parameter is going to be set equal to Star Wars. So the first unspecified item inside the function is going to be set to Star Wars. Well, in the filter function, the first parameter is data, and I don't name the data here, therefore data is going to be set equal to Star Wars. And we get exactly what we'd expect to. Now here, let's do another example. This time we're going to use a Motor Trend Cars data set. And in the piping, what this is going to do, this is going to take the Motor Trend Cars data set. It's going to filter it down to the ones with 8 cylinders. And so at this point, I have fewer rows in my data set. And at this point, it's going to take the fewer rows data set and it's going to select only the columns from miles per gallon to like I think it's axle ratio is DRAT. And so here we can see that we've got miles per gallon through the ratio are the only columns that are included. Now, something to watch out for when you work with the tidyverse regularly drops row names. So watch out for that. Here it didn't happen. Other tidyverse functions automatically get rid of your row names, which I find maddening. Now let's go ahead and filter rows with cumulative functions. So here I have a data set, and this code is just building the data frame. And so this is like the balance of somebody's bank account or something like that. 150, 250, negative 250, negative 50, 30, and 120. All right, so now we can go through, we can go with the cumulative any. So this is CU mini is actually cumulative any, and balance is strictly less than 0. All right, so here, if I look, if I do cumulative, it start adding up. I have 100, 150, and then we have, let's see, 175, and then we keep on going down. And so here it's filtering out for when the balance is less than 0. All right, so you'll notice if I go down this row, down from here, and start doing cumulative operations, negative 25, cumulatively negative 75, cumulative negative 45, and then here it becomes positive. And here it just goes through that process. Now, if I do it here where it's not negative, what it's going to do is, so remember that this is the any function. So once we get negative, everything further forward is kept by cumulative any. Now, here, when I do the negative on this, and I've got cumulative all, this is what this is going to do. This is going to give me everything until things went bad. And it's going to go down the line. And now here we can also go by I can filter by the overall data set, but I can also filter by groups. So like here, I only want the characters who have a mass greater than average over the entire data set, And so here, this is going to be the, roughly speaking, the heavier half of the characters in Star Wars. Now I can change this up. If I do group by, what this is going to do, this is going to go through and this is going to find all the males and females. It's going to take the average of the males, average of the females, and compute that. That's what this mean and the group by combine will do. Well, when I put mass like this, what this is going to give me is the heavier half of the females, heavier half of the males. And so this piping notation is a very efficient way to start doing work on individual subgroups. And this is where I use it the most for my personal work. Well, that's all I got for you. Take care and goodbye.